JKBridge is located in the Distrito Federal, Brazil. Its purpose is linking the Salt Lake and San Sebastián Palma, the central part of the Valley of Ground, through the monumental exit over Lake Paraná. Brasilia needed a clear bridge over a lake that separated its inhabitants from their places of work. It has an incomparable architecture and it was inaugurated on 15 December 2002. The JKBridge is an arch bridge. An arch is a curved beam that forms a semicircular shape. Arch bridge abutments at each end shaped as a curved arch. This type of bridge transfers the weight of the bridge into horizontal poles that is supported by the abutment either side. The design of the JKBridge is asymmetric. The structure of the bridge has a total length of pitch of 1,200 meters, 24 meters wide, 2 length, each with 3 times of the running to walkways on the side for use by cyclists and pedestrians with 50 meters with a length of the span of 720 meters. All this was built with steel and concrete. The JKBridge is a work from the architect Alexander Chan. It has been designed in the spirit of Oscar Niemeyer's realization. Even if it was an expensive project, it is considered by many as a success, and it became quickly one of the landmarks of the city. The graceful arch of the JKBridge play a joke on the eye. As they cross Palma Lake, they abandon any state engineering, greeting and instead jump from state to state, like a child hopping across a stream. According to Sham, the idea was to create a landmark from the enjoyment of the community as much as to simply traverse a body of work. He used structural constraints as a means not of restraint but of expression. The JKBridge is also becoming respected among professionals, an example of collaboration between architecture and engineering. Two large arches dominate the view. An arch crosses over the roadway means to land on the opposite side of the roadway. Rail cables stay between the roadway and the underside of each arch for a sort of tunnel for travelers. The road itself is 3 lanes in each direction, with a sidewalk on each side. The bridge totals 4,000 feet in length, with each steel arch spanning 800 feet. The 80-foot, 24 meters wide roadway covers subway to a radius of 10,300 feet. Below there is a 60-foot clearance allowing a small craft to pass under. The arch reaches a height of 200 feet above water level. There are 16 stays for each arch. The stays are made of strands of galvanized steel protected by a coat of wax and sheets of high-density polyethylene. The lower anchor point of each stay is fixed, while the upper is tunable, making it possible to correct potential. Technology involved in its construction. The foundations use piles combined with concrete pile caps. They needed to resist the horizontal and the vertical components of force generated by having an arch structure. There are 3 types of piers. On the approach span, the central piers and the temporary support. They contain 2 concrete elements. The deck consists of 2 principal sections, the approach span and the central section. They were constructed using different combinations of materials and incremental launching techniques. This means that the deck is created in factory-like conditions of
succeed avoiding costly transportation of large elements. The pavement surface applied to the bridge deck is dermal. This is a unique polymeric thin layer paving product, and it was used because it has many advantages over conventional pavement materials. There are two types of arch, steel and metallic. The method for the construction of steel arches was to support them on formwork until they were complete. This formwork was made from steel trusses and was supported on the deck. During this process, the load was supported by both the permanent and temporary supports and foundations. Otherwise, metallic arch studs were linked directly to the concrete sections with a screw from the foundation, finishing just below the level of the deck. The JKBridge has 7 cables of 15.7 millimeters of diameter, steel wires, which have been galvanized, protected by wax, and encased in high-density polyethylene. High-density polyethylene was used because of its resistance to the sun's ultraviolet rays, making it the best choice over other options available. Finally, the principal alternative method for arch bridge construction is suspended cantilever construction. This involves the use of temporary cable stays to support the structure during construction. It involves the construction of large temporary towers which are needed for the suspension of the cables. Advantage and disadvantage of the bridge for the specific community. One of the main advantages of this bridge is the connection. By constructing a bridge in the chosen location, the travel distances between outlying areas of the region were reduced. This had the effect of increasing the accessibility of the city and its amenities to people living in this community. A secondary aim of locating a bridge at this point on the lake was to eliminate the privatization of the edge of the lake which had occurred in the area immediately surrounding the site. But this bridge was a significant problem with the construction because of the large number of temporary supports used during the process. So, the construction of this bridge was not economic.